Testing code is one of the quickest ways to find bugs in your codebase. But writing tests that just pass, that's easy to do. Writing tests that are resilient to code changes, on the other hand, that's difficult. So let's see if mutation testing can help us write better tests. Hi, I'm Tom from the DevRel team here at Sentry, and today I want to talk a little bit about how we can write better test suites. I know, testing is so boring. So why do we even bother with it? Because it's just too easy to get burnt by some bug that comes up after you push to production. I mean, who else is scared to push on a Friday afternoon? But what if we could test our tests? Say we can make a small change to our code and see if our test will still pass. And that's exactly what mutation testing is trying to do. See, mutation testing is a testing technique where we change a small bit of the code and see if the test suite still passes. Maybe the change is a multiply sign to a divide sign, or an equals becomes a not equals sign. If our tests still pass, they're not strict enough and we can be writing better ones. So these small changes, they're called mutants. And mutation testing works by building a set of mutants and running your tests with those mutations. What we don't want is for those mutants to survive, because that means our tests are too broad. Okay, so let's take a look at an example. Here I have a calculator with 4 functions: add, subtract, multiply, and divide, and some tests for it as well. In fact, I can run test coverage for it, and we'll see that I have 100% test coverage. But does that mean my tests are any good? So let's run mutation testing software, and it comes up with 2 issues. Let's take a look. The first issue shows that we could divide by 1 or multiply by 1. And this makes sense because we can kill the mutant by casting x to a float. But the second issue is much worse. We see that we can multiply by the denominator instead of dividing and still get the same result. We're missing a test that will handle a simple use case. And by adding in that test, maybe 2 divided by 3, we can ensure that our test suite is better suited to handle future code changes. So this looks great. Why wouldn't I want to do mutation testing? Well, simply put, it's really time sensitive. If you were testing for 10 mutants, your test suite needs to run 10 times. For a 5-minute run, that now becomes 50 minutes. The upsides, though, are you have a solid test suite that will be more likely to catch issues on code changes, hopefully making that Friday afternoon push a little less scary.